Okay, in this lesson, we're going to look at two linear relationships at the same time. Okay, or I should say two or more. Okay, in this problem, we're going to look at the first problem together, the zoo problem. A zoo recently celebrated the birth of two new baby pandas. Okay, the data table is showing the weight of Moki and Moki's brother Kappa. The graph is showing the weights of Kappa, okay, over time after 0 weeks, 1 week, 2 weeks, 3 weeks. Okay, we're going to look at three questions and look at their equations. Okay, the questions: which panda was heavier when they were born? Which panda is growing faster? And which panda will weigh more after 5 weeks? Okay, let's look at the first question. Which panda was heavier when they were born? Okay, guys, that's the initial amount. That is the y-intercept. Okay, Moki weighed 1 pound when she was born because it's the number across from 0. So at 0 weeks, okay, when Moki was born, it was 1 pound big. Okay, Kappa, okay, look for 0 pounds on the x-axis. See, so at 0 weeks, Kappa was 2 pounds. Okay, so the y-intercept is the initial amount when you're looking at a graph. Okay, so that means if Moki was 1 pound when she was born and Moki was 2 pounds when she was born, that means Kappa was heavier. So you would type in Kappa for that. Okay, which panda is growing faster? Okay, for change, okay, that's slope. Okay, which panda is growing faster? That's how fast is the weight changing. Okay, so that's slope. So Moki, if you look at the y values of the table, they're going up 4 pounds. The x values are going up 1 week. So Moki is changing 4 pounds every week. Okay, so Moki is changing in weight 4 pounds a week. That's slope. Okay, for Kappa, if you want to find the change, the slope, rise over run. So Kappa is rising 6 pounds, running 2 weeks. So the slope would be 6 pounds over 2 weeks, 3 pounds a week. Now you do have to notice that the y-axis is counting by twos. Okay, so it's going up 6 pounds instead of just 3, because every space is really 2 pounds. Okay, but if Moki is growing 4 pounds a week and Kappa is growing at 3 pounds a week, that means Moki is growing faster. Okay, how much will each panda weigh after 5 weeks? Before we do that, let's look at the equations. I want to show you a different way to find the answer to question 3. Okay, instead of using your data, let's use the equations for questions 4 and 5 first, and I'll show you. Okay, if you want to find the equation for Moki and the equation for Kappa, okay, it's going to look like P instead of Y equals slope instead of X, it'll be weeks, W, plus the y-intercept. Okay, so Moki's slope was 4, the y-intercept was 1, so Moki's equation would be P equals 4 times W plus 1. Okay, Kappa's equation would be P equals slope of 3 times W plus the y-intercept of 2. Okay, so there's the equations for problem 4 and 5. Okay, P stands for pounds, W stands for weeks. So if we want to know how much did each panda weigh at 5 weeks, all we have to do is take the equations and replace weeks with 5 and solve for pounds, P. Let me show you that. Okay, so for Moki, The equation was P equals 4 times W plus 1. Okay, pounds equals 4 times the weeks plus 1. So at 5 weeks, his weight would be 4 times W, which is 5, plus 1. So just take 4 times 5 plus 1. You're just replacing W with 5. 4 times 5 is 20. Add 1, you get 21 pounds. Okay, for kappa, if you want to know kappa's pounds after 5 weeks, you take this equation, P equals 3 times W plus 2, and you just simply replace the W for the number of weeks that they give you, which is 5. So it would be 3 times W plus 2, 3 times 5 plus 2. Just remember to multiply first. 3 times 5 is 15, plus 2 is 17. So Moki is 21 pounds after 5 weeks. Kappa is 17 pounds after 5 weeks. So it looks like Moki must weigh more after 5 weeks. There's a lot in this, guys. Okay, relax with it. Do your best on these, and please tell me if you have questions.